Ever wondered how mirrors and lenses work in optical instruments? Well, you're about to find out. Welcome to the fascinating world of optics, where light bends, bounces, and transforms our perception of the world. Our journey begins with two fundamental elements: mirrors and lenses. So what are mirrors and lenses? Mirrors, as you may already know, are smooth, polished surfaces that reflect light. When light waves hit a mirror, they bounce back, giving us a reflection. This phenomenon is known as the principle of reflection, where the angle of incident light equals the angle of reflected light. This simple principle is behind the functioning of mirrors in countless devices, from the rear-view mirror in your car to the large mirrors in telescopes. Now let's turn our attention to lenses. Unlike mirrors, lenses don't bounce light back, instead they bend it. Lenses are pieces of glass or other transparent substances with curved sides. When light passes through a lens, it changes direction. This change is due to a phenomenon called refraction. Refraction occurs because light travels at different speeds in different mediums. Lenses with their curved surfaces can concentrate or disperse light rays, enabling magnification or reduction in images. It's the principle of refraction at work in your eyeglasses, microscopes, and camera lenses. Interestingly, while mirrors and lenses may seem quite different, they share a common purpose: to manipulate light in order to help us see better, further, or differently. They are the unsung heroes in our daily lives, enabling us to drive, read, observe distant galaxies, and even capture memories. Understanding mirrors and lenses is the first step towards appreciating the complex interplay of light and optics in the instruments we use daily. This foundation will help us unravel the intricate ways in which these two elements work together in optical instruments. Now that we know what mirrors and lenses are, let's delve into the fascinating ways they work in optical instruments. Mirror, mirror on the wall. Who's the most reflective of them all? Mirrors, of course. Now that we've got that out of the way, let's dive into the fascinating world of mirrors in optical instruments. First, let's remind ourselves of what a mirror is. Simply put, a mirror is any surface that reflects light in such a way that, for incident light in some range of wavelengths, the reflected light preserves many or most of the detailed physical characteristics of the original light, called specular reflection. This is different from other light-reflecting objects that do not preserve much of the original wave signal other than color and diffuse reflected light. Now onto plane mirrors, or as you might know them, flat mirrors. These mirrors reflect light in a straightforward manner, producing a virtual image that is the same size as the object. They are the simplest form of mirror, yet they are incredibly important in optical instruments. So, how exactly do mirrors play a part in optical instruments? Well, let's take telescopes as an example. In a reflecting telescope, a large parabolic mirror collects and focuses light onto a smaller flat mirror, which then reflects the light into the eyepiece. The larger the mirror, the more light the telescope can collect, and the better its resolution. Another example is the periscope. Used commonly in submarines, periscopes use two mirrors arranged at 45-degree angles to allow the user to see over, around, or through obstructions. The light bounces off the first mirror, travels down the tube, then bounces off the second mirror and into the viewer's eye. So, we see how mirrors play an absolutely vital role in optical instruments. But what about lenses? Well, let's find out. Ever used a magnifying glass to read tiny text, or perhaps to burn a leaf under the sun? That's the power of lenses. Lenses are fascinating objects that manipulate light in a different way than mirrors. Where mirrors reflect light, lenses refract it. Refraction is the bending of light as it passes from one medium to another, like from air to glass. Let's consider a magnifying glass. When you bring it close to an object, it seems to enlarge it, right? That's because the lens is bending or refracting the light rays that come from the object, causing them to diverge and form a larger image on your retina. Lenses come in two main types: concave and convex. A convex lens, like the one in a magnifying glass, bulges outward. It's thicker in the middle than at the edges, causing parallel light rays to converge or come together at a point. This ability to focus light is why convex lenses are used in devices like cameras and microscopes. A concave lens, on the other hand, is thinner in the middle and thicker at the edges. It causes parallel light rays to spread out or diverge. This spreading out of light makes objects appear smaller, which is why concave lenses are used in things like peepholes in doors and some types of eyeglasses. Now let's talk about cameras. The lens in a camera focuses light onto a film or a digital sensor to create an image. The lens can be moved closer or further from the sensor to adjust the focus, just like how you can move a magnifying glass closer or further from an object to see it more clearly. In microscopes, a series of lenses work together to magnify tiny objects. The object is first magnified by the objective lens, and then the image is magnified again by the eyepiece lens. So, lenses like mirrors have a crucial role in optical instruments. Now that we've seen how they work individually, let's see what happens when they team up. When mirrors and lenses join forces, they create some of the most incredible optical instruments you could imagine. It's like a dynamic duo of light manipulation, where each partner brings its own unique talent to the table. Mirrors, they reflect light, while lenses bend it. But when they come together, they create something greater than the sum of their parts. Take telescopes, for example. These are not just long tubes aiming at the stars, they are beautifully crafted devices where mirrors and lenses work in harmony. The primary mirror at the base of the telescope gathers light from far-off galaxies and stars, effectively capturing a snapshot of the cosmos. It then reflects this light towards a secondary mirror, which redirects the light again, this time towards the eyepiece. Now this is where the lens comes into play. The eyepiece lens takes the light that's been bounced around by the mirrors and focuses it, sharpening the image so that when we look through the eyepiece, we get a clear, magnified view of distant celestial bodies. It's like having superhuman vision that can see into the far reaches of space. And then there are binoculars, another testament to the teamwork of mirrors and lenses. In binoculars, lenses at the front gather light, much like the primary mirror in a telescope. This light then bounces off a series of mirrors inside the binoculars, changing its direction and making things appear closer than they are. Finally, another set of lenses at the eyepiece focus the light, providing a clear, magnified image. So you see, mirrors and lenses are like the best of friends, each bringing something special to the party. They work together, complementing each other's strengths and compensating for each other's weaknesses to achieve a common goal: to manipulate light in such a way that we can see things that would otherwise be invisible to the naked eye. So, mirrors and lenses together can achieve some amazing feats. But what are the key takeaways from this discussion? We've learned a lot today about mirrors, lenses, and how they shape the world of optical instruments. We embarked on this enlightening journey by introducing ourselves to the fascinating world of mirrors and lenses. We discovered that mirrors, with their reflective properties, and lenses, with their refractive abilities, are not just simple objects, but are fundamental components in a wide array of optical instruments. We then delved into the realm of mirrors and their applications in optical instruments. We saw how mirrors, whether they are flat, concave, or convex, play pivotal roles in devices like telescopes and microscopes, magnifying our view of the universe or bringing the minute details of the microscopic world into clear focus. Moving on, we explored the world of lenses and their significant roles in optical instruments. From the simple magnifying glass to the intricate lens systems in cameras and binoculars, lenses manipulate and channel light in ways that enable us to see the world in more detail, in different scales, and sometimes in entirely different perspectives. In our fourth scene, we brought mirrors and lenses together, examining how these two components often team up in optical instruments. We learned how the interplay between mirrors and lenses allows for complex light manipulation, leading to the creation of more sophisticated devices like projectors and advanced telescopes. To sum up, mirrors and lenses, with their unique properties, prove instrumental in the world of optical instruments. They help us explore the cosmos, observe the tiniest life forms, capture moments and project images, among many other things. They truly are unsung heroes in our everyday lives. Next time you peer through a telescope or snap a photo with your camera, Remember the hard-working mirrors and lenses that make it all possible. Thanks for watching.